You are at the 2021 Volunteer Water Quality Monitoring Microplastics training. So microplastics is one of our new parameters that we're testing. We also test under the kind of banner of water quality monitoring. We also test nutrients and bacteria, and we have our invasive species monitoring. And so microplastics is being added to the docket. And so this is our pilot year. So I'm excited that you're all here, because for a while it's just been really in our own heads as we've been working through it. So it's nice to see it get rolling. So quick overview of what we're going to be doing today. Just quick introduction, overview of what microplastics are, the training, and then plenty of time for questions at the end. And I know some of you have been involved with CRC before and have done monitoring before. So I welcome all of your expertise. So just a quick introduction. My name is Gabriel. I'm the lab manager at CRC. And so I currently process all of the bacteria samples that come in, so E. coli. So I'm running the lab in the summers. And then Aliki, if you want to introduce yourself briefly. I think most of you have spoken with Aliki. But
yes, thank you. Hi, everyone. I'm the ecology planner at the Connecticut River Conservancy. And I've been emailing everyone about this program. So if you have any questions about this program, logistics, or other volunteer programs, I'm the person.
Yes, Aliki has been instrumental in getting the program out of my head and getting me to have it put it down on paper. And then she's the one that's really kicking it off by getting other folks involved. So a quick overview of the problem with microplastics. So we are defining microplastics in this context as, I see someone coming on in. So microplastics are small particles of plastic that oftentimes represent the degradation or breakdown of larger items. So the larger pieces of trash that you might see, so styrofoam, plastic bags, bottles, textiles, rubber, tires, really anything kind of that runs the gamut of plastics. Will break down into these very small pieces that are generally less than 5 millimeters. So that's, if you think about 1 centimeter is 10 millimeters, so about half a centimeter. And I like to think kind of smaller than the little tip of your pinky nail. So really hard to see, really hard to track. And that's one of the problems that we're seeing is, there's all this information that says, microplastics are ending up in our food, in our fish, in our environment, but they're hard to find. And oftentimes kind of skirt by us. So this is an effort on behalf of CRC to kind of try and see what happens in our rivers and just give us a little bit more information. So for the purpose of the study, we're breaking down microplastics into a few different categories. So if you look on the pictures across the bottom from left to right, so on the left you see a fiber. Then you see pellets or beads. So sometimes that's microbeads. So there's a lot of information about that coming out in like the little microbeads that are in face wash sometimes, or there's this thing called a nurdle, which is a little spherical ball that is created for the purpose of making something larger so they like make up a larger piece of plastic. But if those enter into the rivers before they're made into larger pieces of plastic, they just they float through the systems. So foams, kind of that squishy, spongy looking thing in the middle. Films or fragments, so you can think of that as like maybe a little piece of a plastic bag, or the little plastic that shows up in your energy bills, right? That plastic window and an envelope. And then fragments on the far right. So kind of a little bit larger and a little bit maybe more sturdy pieces of plastic that are obviously breakdown of larger plastics. So why do we care? It's kind of a growing concern in recent years about plastics, including microplastics in aquatic environments. So I know in our work at CRC, we're finding bottles, rubber, bags, kind of the whole, anything you can name, we find it in the Connecticut River and the surrounding tributaries. So this is just building on that work to say, yes, we're seeing these huge pieces of waste, these huge pieces of garbage in our systems, but what does that mean for smaller pieces? A little bit harder to say, in the source to sea cleanup, you're not collecting tiny, tiny pieces of plastics. These are the plastics that are just getting washed through the system time and time again. So the problem with microplastics and plastics in general is they last for hundreds of years and they're really hard to clean up. They accumulate in the food chain, and as with things that are happening, whether it's bacteria or plastics or anything in the rivers contribute to ocean plastic pollution. So everything that's running through the systems in New England and into the Connecticut River ends up in the Long Island Sound, particularly microplastics, because, like I said, there's not a lot of, like, where you might see a tire sinks to the bottom and it stays in one spot. Microplastics are often just kind of circling through these systems. So the CRC Microplastics Monitoring Program, just a few details. We do want to make sure we thank the Massachusetts Environmental Trust. They are the folks, you can see their logo in the bottom right, and they're the folks that are funding this activity and this pilot program. We had originally applied in 2019 and we weren't awarded it. We changed our proposal a little bit, and then in 2020 we were provided with a grant to get this launched off the ground. It builds on our trash advocacy work and our source to sea cleanup. And there isn't really any monitoring that's happening in the Connecticut River watershed. So we're building this from the ground. We're looking at other studies. We've spoken with folks at the Ocean Conservancy who did a study on the Hudson. There's work happening in the Great Lakes region. We've been working with some folks at Mississippi State University who have a microplastics monitoring program, looking at beaches. And so we are kind of trying to take all of these pieces from programs around the country and create something a little bit close to home. So this year, what I've been working on is creating the protocol and the systems for sampling and analysis, getting all the supplies. We just got our microscope up and running so we can process the samples once they get back to the lab. But the first step is really working with you folks to get the samples collected, because without you, it's just me in the lab with the microscope with nothing to look at. So I'm really happy that you folks are here. And the biggest goal is just to fill a gap in knowledge around the amount and type of microplastics in the river. And again, this is a pilot year, so we're kind of starting at a base level, and we don't have a lot of expectations about what we're going to find and what it's going to look like, and we're hoping to build on this in the coming years. So to the down and dirty, the logistics of the program. So we've selected 9 sites in Massachusetts because it is supported by the Massachusetts Environmental Trust. And the sites in Massachusetts that we chose are mostly along the Connecticut main stem. So similar sites to where we sample nutrients and bacteria. And then there's a couple sites. So you'll see on the left side, it says the water body. So most of the sites in Massachusetts are along the Connecticut River, but you see Sanders Brook, which is in Heath, and that's kind of a control site. That's just a small brook in the middle of not a very populated area, and that's just kind of a control that we're using. And then we're also doing one on the Deerfield River, looking at one of the major tributaries in Massachusetts. And then CRC is funding 2 sites in Connecticut and then 2 sites in Vermont, New Hampshire. Again, sites that we test other parameters at. And those, again, are along the Connecticut River or along a major tributary. So we see that for the West River and Brattleboro. And then again, the Westfield River in Agawam is another major tributary. And so that is where we are collecting sites for the year. So sampling logistics. We are currently in the beginning phases of the kind of off the ground portion of this. So the first step is distributing supplies, and we're going to get those out to folks for this August. And Aliki and I will send out emails to follow, an email with details to follow about how to collect those. And Aliki and I are figuring out, if folks aren't able to come to Greenfield, Aliki and I might be taking a road trip. So some information to come on that. The samples will be collected at, like I said, 9 Massachusetts, 2 Connecticut, and 2 Vermont, New Hampshire sites. What's unique about microplastics is there's no time of day restrictions, and there's no specific day that we need them collected. So in order to kind of provide you folks the flexibility, We're just asking that when we decide on a 1 week window, that it's collected sometime within that 1 week window. So someone might collect it at 6 a.m. on a Monday morning. That's the time that they have available. Someone could collect it 8 p.m. on a Thursday afternoon. So as long as it's kind of collected within that 1 week window, we feel great about that. And if there is an issue, of course, just reach out to us, because if it needs to be, the following Monday, we're a little bit flexible there as well. So we're going to collect 2 samples, one hopefully late August, early September, and then one maybe early to mid October. And so we ask that samples can be delivered by the volunteers back to the CRC lab, or we do also have our office in Brattleboro, and we have an office in Hartford, Connecticut. So in coordination with our river stewards, we might be able to do a drop off there, and then they'll bring them up to me in the lab when they're available. And what's unique about the microplastics program is, like I know with the bacteria, we have a 6-hour window. Once it's collected, we can only have 6 hours to process this sample, but for microplastics, we're not worried about the samples and the microplastics degrading within the time in between collection and analysis. So if a sample is collected in August, we might not get to process it until October, and that's okay. So a lot more leeway there and flexibility there in terms of sampling. I'll talk a little bit more about this later if folks are curious, but once samples arrive at CRC, we process them with a vacuum pump that goes through a filter, and then we use a microscope to analyze it. And I have some pictures later to show you, but from there, the data is analyzed and reviewed and interpreted on an annual basis, and we'll be putting out reports annually, and all volunteers will receive a copy of the results. Right now, I think for the first year, we're going to look at like presence versus absence. So are there microplastics, yes or no? And then we're going to start kind of identifying, if we see it, we're going to start identifying it based on those types that I showed you earlier. And then as the years progress, maybe we'd be able to kind of really hone in on where these plastics are coming from. But that's a kind of a future. We don't have the capacity to do that this year, but it's something that we're thinking about. All right, so what will we provide you for sampling? So all samples will be collected in a 1 liter, I think it's so it's like a 32 ounce. So it's really a quart, just under a liter glass mason jar with a metal lid. And so normally our samples are collected in plastic bottles, but as you can assume, we're trying to avoid plastic right now based on the fact that we're testing for microplastics. So we're trying to really cut down on as much contamination as possible. We'll provide quality control supplies as needed, and I'll get to that in a few minutes. A thermometer for taking the temperature, a chain of custody form. Again, I'll go over that in a few minutes. A field sheet. Everyone's going to get a folder with instructions. So everything I say today is also in writing, because I know some folks learn best that way. And then we're also going to be providing you with a CRC canvas bag, conveniently usable for us to deliver the samples to you and for you to transport the samples back to us. But then that is for you folks to keep as a token of our appreciation once you complete the sampling. All right, so there are 3 different types of samples that we might ask folks to take for us. So the first is a standard sample, which is just a 1 liter or 1 quart mason jar filled with river water, and I'm going to explain later how to take that. The second one is a field blank, and a field blank is really testing for contamination. It tests that volunteers are not pouring plastics in addition to the river water they're collecting. They're not pouring pieces of plastics into that sample. So the way that a field blank is collected is it's the same bottle, but you'll be provided with an empty bottle, and all of these bottles will be labeled. So there won't be too much confusion there. And again, the instructions will be provided. But for the field blank, volunteers will be provided with one of these bottles and then a second bottle that has water in it. And that water is water that I will provide that's sterilized already and that we know doesn't have microplastics in it. So then to do that, all you folks will do is they'll take their empty bottle and they'll take their full bottle of sterile water, and they'll transfer the sterile water into the empty bottle, and that's to see whether or not there are microplastics in the air. And so that's another thing, is that we think of microplastics as being these, kind of pieces of chunks of plastics, but there's been studies that say that microplastics are also in really fine particulate form moving through the air, whether they come from degradation of materials or we're seeing it also from dryer vents. That's a really big issue with contamination of microplastics. So trying to figure out is if in that moment the microplastics exist elsewhere. And I'll go over those instructions later. And then the second field type of sample we might ask folks to take, and you'll be provided with just two empty bottles. And in that circumstance, all you would do is to fill both bottles simultaneously. And that's a check for me, because when it gets to the lab, that tests whether or not I am looking at the samples objectively, because we should see a similar amount of microplastics in both of them if we do see it. All right, so along with every, in that folder with the instructions and the chain of custody, you'll get a stack of field sheets. And so I'm just gonna run through pretty quick what you'll see on these field sheets. It's pretty self-explanatory, but just wanna make sure we cover the bases. So sample name or sampler name, so that's you, the date, the time that you take the sample. And then the important information that needs to be written on every single field sheet is the site ID code and the site description or name. So the site code is going to be written on top every bottle. You can see I kind of wrote on the top here. Every bottle will have the site ID code on it. And so for Barton's Cove example, we have that site name is Connecticut River at Barton's Cove ramp. And the site code is MAG4, MAG4. So that'll all be written on the top of the bottle. And that's just to check that you got the right bottles, because we want to make sure coming back, you had the right bottles and then we get the right bottles back. So you'll just make sure that you write that on your field sheet. And then the same thing, the site description is the site name and water body. So for example, it would be Connecticut River at Barton's Cove. Again, just another check to make sure that we have the right bottles. Did you collect, so number 3, did you collect a QC sample? And here it's a check, a yes or a no. If I asked you to collect a field duplicate, so a second bottle, you'd check yes. And if I asked you to take the field blank, so the one where you pour the sterile water in, you'd say yes. And if I just gave you this one bottle, you would say no. For number 4, if you said yes, was it the duplicate or was it the blank? And that, again, just to make sure that we know what's coming back. Number 4, oops. Oh no, yeah, sorry. Number 5, please describe what you're wearing. So one of the big things with microplastics that we're going to try and track down, and it's really difficult and we don't know if we're going to be able to do it, but something that we try to track down is possible contamination. And one of the biggest things is clothing. And so we ask that folks write down what they're wearing. So right now I'm wearing it's cotton. And so what I would write down is I might write down, I'm wearing a white cotton t-shirt with white and black cotton t-shirt. And I see, someone in there maybe wearing an orange sweatshirt. I don't know what material it might be. Maybe you say I'm wearing a purple t-shirt that's 100% polyester. And that really just helps us say, if I see a purple fiber, and someone wrote that they are wearing a purple polyester t-shirt and blue nitrile gloves or blue gloves and black khaki pants, then if I see that purple piece, that purple like filament or film or fiber in that sample, I'll write a note of that when I'm analyzing the results. And I'll say, okay, this is probably possible contamination. So as much information as you can give is helpful. If I'm wearing polka dot pink rubber boots, I'd probably write that as well. Just continuing on with filling out the field sheet, weather observations. Again, this is just a checkbox, and this is just so we can kind of get an idea of what the conditions were when you were sampling. So just let us know if there was a storm in the past, or storm, rain, showers, overcast, sunny in the past 48 hours, and what it is currently. Number 7, site observations. Please select the options that best fit site conditions. So again, this is just once you get to your site, taking stock of what you're seeing. Is the water clear, cloudy, muddy, green, brown? Is there an oil slick? Are there debris? Do you see, no debris, plant matter, surface scum, pollen, trash? anything that might be of interest. I'll skip just to number 10 for a second. If these check boxes don't cover what you see, please use the other comments section, or even flip it over if you have more notes than can fit there, and just tell us anything that might be relevant. It might seem a little silly or redundant, but as we're thinking about possible contamination, any information that you provide us is helpful. So again, if you choose, we would love to get pictures of the site. So if you choose to take pictures, it's a really helpful tool for us to kind of get the folks who are analyzing the samples in that headspace to see, okay, this is what it looked like there. So if you take pictures, just write a brief description of the picture, and then send the pictures to us as well, and we'll provide an email. Water and air temperature, we'll be providing thermometers, so write the temperature, and the thermometers are in Celsius, so air temperature and water temperature. And again, 10 is other comments. And I'm going to keep cruising, and again, if you have questions, we will have time at the end for questions. All right, so collecting temperature data. Just gonna take a quick sip of water. I just want to let you guys know, again, all volunteers will receive written instructions, so detailed instructions to follow. So to collect temperatures, we ask that folks do air and water temperature. So we ask that upon arrival at your site, you hang the thermometer in the shade and just wait 2 minutes just so that the thermometer can adjust, and read the temperature to the nearest degree and write that on the data sheet. And again, there's that little box on the data sheet where you can write it. Once you've collected, we ask that you take air temperature first, if possible, because your thermometer is probably already adjusted closer to the air temperature already. So it just saves time to take that first. And then once you take the air temperature, you place the thermometer in a shady area of the river. I generally attach it to a rock or hold on to a string. They have kind of like wristbands on them, and so that helps to kind of hold it or stick it somewhere. And then after 2 minutes or so, once it's adjusted, record the temperature on the data sheet or on the field sheet. All right, this is kind of just general notes about collecting a microplastic sample. So we ask that you use only the sterile bottles that you've received from CRC. We'll take the time in the lab to rinse them and make sure that they don't have microplastics contained within them. And we ask that you don't open them until the moment that you are ready to take a sample. And I'll explain in the next slide kind of what that process looks like. Before taking the sample, so maybe on the side of the riverbank, or just even when you get the bag with the supplies, make sure that the sample bottle is labeled with the proper code and description, and then that is going to match the data sheet that we provide you. So, and then the last bit is just a safety concern. If you are sampling from waters that you know to be contaminated with sewage, or just or areas where we see high bacteria count, we ask that you wear gloves to protect yourself, or just rinse your hands or sterilize them after collecting the sample. And that's just we trust that you are the best judgment there. And the same goes if there's been a heavy storm and really high levels of water, or you're not able to sample, just you folks make the best choice about your safety. So we ask that you just kind of use some common sense, and if it's not safe, don't sample. It's not worth it to us if it's not safe for you. All right, so the nitty-gritty of collecting a standard microplastic sample. So again, this is if you just provided with one bottle, pardon me, one bottle to collect the sample. So again, we ask that you keep the bottle sterile. So that means not opening the bottle until it's time to sample, and not touching the inside of the bottle or the cap. So just as you're opening it, we ask, the tricky thing about, I don't know if any of you have ever canned anything or eaten a can of pickles, but the tricky thing here is that the bottles that we have a ring and have one of these inside, the lid inside. So just be careful when you're taking off the top to just hold that ring in there. And try not to drop it in the river and let it float away. We looked into using the other kind of one piece tops, but they're all plastic, of course. So just kind of be careful to hold on to that. So you're actually not going to open it until you get into the water. So we ask, again, leave that closed until you wade into the water to a reasonable and safe depth. And when possible, we want you to sample where the water is flowing strongest. So I'd probably wade out maybe, 10 or so feet if I could, and then walking upstream from where I started. So trying to avoid stirring up the bottom sediment. So what we're really trying to avoid here is, for some samples when we're collecting stuff for turbidity and there's natural sediment in the river, it's okay to get a little bit of that bottom sediment. But what we're hoping for here is not to have that, because once we're processing in the lab, sometimes it's really difficult to tell the difference between natural sediments and microplastics. And so the least contamination we have, the better for us in the end. So wade into the stream, carefully walk upstream to try and avoid stirring up the bottom sediment. And then once the disturbance from wading in returns to normal, you're going to take the sample. So again, keep the bottle closed until you're just ready to sample. Get yourself situated, make sure you have strong footing before you open the bottle. So to collect the bottle or to collect the sample, you're going to face upstream. You're going to remove the cap, like I said. And what you're going to do is you're going to hold the bottle in the middle like I'm doing here. And you're going to plunge it. You're going to kind of turn it down, plunge it neck downward, fill it up completely. And then you're going to turn a little bit and dump it downstream. And so we're asking you to do that twice just so that it rinses the bottle a little bit. So again, you're going to take it, you're going to kind of imagine you're scooping up something, and then you take it and you're going to dump it downstream again. So once you've done that twice, you're just going to wait for a second. The water is going to keep flowing by you. You're facing upstream or into the current or the direction that the water is coming from, even if there's not a lot of current, just facing where the water is coming from. And so after rinsing, you're going to dip the jar in one more time. So again, kind of in a scooping motion. And you're going to hold it mid-height in the river. So we don't want you to hold it on the bottom because we don't want sediment. And we don't want you to hold it on the top because the top is not characteristic. You get a lot of things floating on the top. What we're trying to get is mid-height, bottle is submerged. You're getting it from the middle of the river profile. And so the tricky thing here is I'm going to ask you to place the cap onto the bottle underwater. Why do we do that, right? And that is to decrease the possibility of the contamination from the things that you're wearing and the contamination from the sediments on the bottom and the contamination from what's floating on top. So again, you're scooping the water in and you're putting the cap on mid-height and just tightening it. It doesn't have to be, if you meet a little resistance, just tighten it as tight as you can. And then when you pull it out of the river, just fully tighten it. And record any information that might be relevant about collecting the sample. Again, all these instructions will be on the sheet that we give to you. So collecting a quality control sample. So I just went through what collecting a standard sample would look like. For collecting a field duplicate, what you would do is immediately after collecting your standard sample, you'd repeat the process with your second bottle. Exactly the same, don't change a thing. Just collecting that second empty bottle. And again, it'll be written on the bottle that it's a field duplicate. So you'll know which one you're collecting. And then remember on the field sheet, that's where you check, was this a quality control sample? Yes, it was. And then for the field blank sample, like I said earlier, immediately after collecting your standard sample, return to the stream bank and collect your field blank. So what you're going to do is you're going to open the extra bottle that we provided. It'll be empty. Checking it's correctly labeled. Again, do not touch the inside of the bottle. So you're going to take off the top again. You're going to open the sterile water that we provide you. And all you're going to do is pour the sterile water into the sample bottle that we provide you. Cap the field blank, cap the sterile water. If there's any left, you can dump it out. And then check the correct box on the field sheet and return both bottles to CRC with your other samples. And that's just so we make sure we get all the bottles back. And a quick note is that quality control samples are always collected in addition to standard samples. So if you said, oh man, I didn't get enough bottles, or oh, oh, I guess maybe I should just collect this one instead. Nope, you're always going to collect the actual sample, the standard sample. And if I ask you to collect quality control sample, it'll be in addition to. So you're always going to have at least one sample, and sometimes you might have a second one. All right, the last little bit of paperwork is that we ask you to fill out a chain of custody form. And a chain of custody is just that it helps us track if there's something wrong with the sample, or if we have any questions about the sample. This is how we track down who completed the sample. Because it's easy for me to, when I'm collecting all the samples, it's easy for me to forget who did what. So this just helps me be able to go back to you if I have any questions, or say, oh, can you remind me, like I'm seeing a bunch of fibers of this color. Is that something that would make sense? So that's another check, another quality check, so that I can go back and ask you folks questions. So again, sample name, date, your name and the date, pretty self-explanatory. Number 1 is the site description. So again, that's the site name and water body, Connecticut River at Barton Cove. Site code, it will be written on the sample bottle. Those are all established codes already that match up with the sampling that we already do at CRC. The time, when did you sample? Comments, again, any relevant information. You'll see that there's multiple lines. So right, you see 1 and then 5 and then a bunch of spaces under that. If you are collecting multiple samples, you can use one field sheet. If you're collecting a field blank or a field duplicate, I ask that you write that. You list it here again without the site name. Number 6, you'll sign off that you were the one who collected it. We'll write who you dropped it off or where you dropped it off and when. So I'm just this is an example one that I filled out as if I took a sample at Barton's Cove. So my name, the date, the site name for the first sample is Connecticut River Barton's Cove. The site ID is MAG 4. Take the time. I would check off that I collected a microplastic sample. It didn't come through on the writing there. And then here, an example of how I would write that I took a field duplicate. I'd write field duplicate in the comments section. I took it at 8:30. And this site code or this QC ID is already pre-established. So if you got a site that said FD field duplicate is what that stands for, 2, you just write that code there. If it was a field blank, it would probably be FB. So FB for field blank, FD for field duplicates, and that'll be written on the bottle. And so you just want to write that ID, and you can leave for field blanks and field duplicates, you can leave that site name blank. So I relinquished it. I passed it off to our water quality monitoring coordinator, Ryan, at CRC Lab. I dropped it off at 3:30 p.m. on the 14th. And you'll notice here that I wrote the 14th as the day of delivery. It's not the 14th yet, but I wrote the 11th as the day of collection. So again, that's showing that you can take it at 8:30 on, yesterday was the 11th, so 8:30 on a Thursday, and I could drop it off at 3:30 on the 14th, and that's not a problem. All right, so that's, pardon me. So that's all the information about how to collect a sample, information about microplastics. And this is just, I wanted to give you folks an update of kind of like what happens after it gets to the lab. And we are hoping, I'm doing some of the preliminary analysis and working through kind of the standard operating procedures, but we're hoping that as time and the years progress, that this could become kind of a fully volunteer process. And so we are hoping that folks might be interested in doing some of the analysis and processing in the lab. A great way for folks to get into the lab at CRC if they have lab experience or if they want some more lab experience. So this is just some pictures of what happens once it gets to us. So here on the far left, the first picture is a picture of a bottle containing a water sample. The second picture here is it's a vacuum pump. You see the vacuum pump is this gray handheld device, and it's connected to a little bit of tubing to a filter, flask, and funnel. So what you see here is kind of this larger receptacle on the top, shown again in the second one. There's a little white paper funnel, gridded paper funnel that allows water to go through, but doesn't allow the microplastics or the sediment to go through. So we pour the sample into the top vessel, and we use this hand pump to pump the water down into this flask at the bottom, and then we dump the water. So we use the pump to change the pressure and pull the water down into this flask, leaving all of the sediment on this filter. The filter then comes out of, it's sandwiched by magnets in between the vessel on the top and the vessel on the bottom. We pull it out with tweezers, we put it on a petri dish, and then we take that petri dish and we put it under our microscope. And so then once it's on the microscope, you can see that it has little grid lines on it, which just help us determine size of microplastics. And then you can see here an image of what that might look like when you're looking at it through the microscope. So you can see it's pointing to this kind of blue fiber, this blue string right here, and that had been identified as a piece of microplastic. So that's the process once it gets to the lab. I'm happy to talk more about that, but I just wanted to give folks a run through of what that looks like. All right. I know I spoke quickly. I know that's a lot of information. Please ask questions. There's more information on our website, and all volunteers, again, will be provided with written instructions for every process that I just went through. So I'm going to turn it over to Aliki and see if she had anything else to add. But thank you again. I'm really happy to have you guys here. I'm really excited about this project. It's been fun to put it together in the lab. So I hope that we get some good data. I'm really happy to have you. So thank you.
Thank you so much, Gabrielle. I'll give you guys a second to ask all your questions. I do want to say, first of all, thank you for this very instructional lesson. I thought it was super interesting. I had no idea that's how we did the whole thing. So I'm really excited for all our volunteers. And so I just want to talk a bit about the process of what to expect next in terms of supplies. So as Gabrielle mentioned, we'll be going around delivering supplies to those of you who can't make it to our office in Greenfield, but if you can, we'll have them ready for you here in Greenfield to pick up. And essentially not all volunteers at this point will get supplies just because we don't have enough for everybody. We will get supplies for the main samplers of every site and the two following backup samplers. So there's an order to this. I'll follow up with more details via email. But in the meantime, if you don't hear back from me in terms of like how supplies are happening, don't be worried. We haven't forgotten about you. It's just there's an order to things. And again, this is our first monitoring program for microplastic. So everybody will have a chance in the coming years to essentially participate in this program. And your order will stick throughout the years until you tell us that you don't want to do this anymore. That's just wanted to clarify how the volunteer logistics go. And I want to give everybody time to ask their questions. I think there's already one in the chat, Gabrielle.
Yes. First, I'll just show you, this is our new, Aliki did a great job ordering these canvas tote bags. So these are new bags. This is how we will deliver the samples. And then again, this is yours to keep after the fact. So just thought I'd show you, if you needed more convincing, there's a bag in it for you. Okay, first question from Jamila is, how deep exactly do we need to be in the river? Knee deep, waist deep. So this one, it's up to your discretion. So I think if you could go to, and in some places, the Connecticut River in some places is, 300 feet wide, and in some places is 2,000 feet wide. So it really depends on the place that you're sampling. And so I'm not asking you to go out into the middle of the Connecticut River where it's 15 feet deep and take a sample. If you can get up to your knees, or up to hip level, if you have hip waders, or if you have someone to go along with you to make sure that's safe, great. If not, knee deep is great. We're just hoping that there's a little bit of a current where you're taking it. because I think what we don't want is we don't want stagnant water. We're trying to get the microplastics that are flowing through the system. So as long as you can get to a current, that's all we ask. And I do think most places in the Connecticut, once you get a couple feet into the river, you see the current. And if at your site it's identified that that's not possible, we do have sampling poles that are 10-foot long poles. We can strap the bottle to the pole, and you can reach out and do that if it is not possible for you to wade into a point where it's safe. We had thought about like bucket sampling from bridges, but all the bridges across the Connecticut River are too high and too dangerous. And also the buckets we have are plastic. So we're sticking with the glass grab samples for now. Yeah, so again, knee to hip height if possible, just looking for a current. And again, if it's 4 feet deep, we ask that you take the samples at 2 feet. So again, not the sediment at the bottom, not the water at the top. And then I think the second part of Jamila's question was, can we look at the microscope at the samples can we look under the microscope at the samples if we want to? Yeah, I think that I'd love to have folks. I think that we're going to try and train some volunteers to do the analysis of the samples with myself and our water quality monitoring coordinator kind of doing some of the QCs to get it up and running. But yeah, if you want to come take a look at your sample once we process it, absolutely. And I think that the only question there is we do have strict limits on what COVID protocols look like in the office. And so we would just need to go over what that means to have a visitor in the office and what the expectations are around that. Question number 2, I see is the Haddam ramp coordinates listed bring us to a private dock next to a marina. Have questions about safety wading into water near a boat dock. Great question. I think I can double check I was part of those coordinates by our Connecticut River steward who does coordinates our water quality monitoring in Connecticut for bacteria samples. So I'll double check with her that those are the right coordinates. And if wading isn't an option near a boat dock, I think it might be best to get a sample pole and maybe take the sample from the dock with the pole, 6 feet off the dock. So you don't necessarily have to wade there. And that can be a site-by-site question as that stuff comes up. So question number 1 for me to look up is the Haddam site.
And there's a question from Chris that was missed just above Lauren's.
Thank you, Lakey, for keeping me honest. Let's see. Okay. Chris, oh yes, you're Putney Rowing Club. You've been taking water samples off our dock at the rowing club. Still acceptable, or should you go in the river without disturbance from the shore? I think if you can get, maybe this is another example where we use a pole. If you can get, maybe, I know for like bacteria samples, it's okay to kind of skim off the top. I think if you're able to get down deep enough to get a little bit of that current, great, off the dock. If not, I would say maybe use a pole just so you can get deeper, or wade in from the side. We just want to avoid taking just the top. So it depends on how high your dock is relative to where the water is.
I'll just say it's depends on the water level at the time when I go do this. I mean, it's good 8 foot down, definitely to, but it might be more than that. It depends on the rain. But when you say a pole, like how long a pole? I've never done it that way, so.
The pole is, I want to say that is an 8 foot pole, 8 to 10 foot pole, because it's taller than I am. I'm almost 6 feet. Yeah, it's probably 8 to 10 feet, and it has, you just kind of wrap there's a bungee cord situation and a little platform, and you wrap the bottle to it, and you stick the bottle out, and you pick it up that way. The only tricky thing is that you just have to make sure you have the right balance, because it can get a little heavy. 10 foot pole, liter of water.
Okay. Yep. All right. Yeah.
I might say wading.
Yeah.
Yeah. Okay. I see 2 new messages. Please distinguish between field blank and field duplicate. Okay, so a field duplicate is when you collect your first regular sample and then you collect second sample exactly the same way. And that's just so that we're seeing if you collect two samples, are they done the same way? That's checking me. That's a QC check to see whether or not I'm doing my job in the lab, and they should be kind of similar. A field blank is me checking, are there contaminants in the air? Are any of our volunteers putting microplastics into the samples? I don't think so, but that's checking sterile water, devoid of any microplastics, being transferred into a regular container to check in the transfer process, are any microplastics being added to the sample? So that's just to check contaminants. Is that helpful? And again, will be written on all of the instructions. What is the smallest plastic particle size that you can observe at the CRC lab? So what's the microscope that we're using, I think has a 40x magnification. And I'm going to look at our data sheet in the lab, and we have identified, so the way that the plastics break down is greater than 2.5 centimeters is macroplastics, easily seen by the naked eye. Mesoplastics is above 0.5 centimeter to 2.5 centimeters. Again, like size of the tip of a pen, easily identified by the eye. Large microplastics are 1 millimeter to less to 5 millimeters. Then we have small microplastics, and then nanoplastics. And so I think we're thinking that, again, we haven't run any of the samples yet. So we're thinking that we're going to identify the mesoplastics, so larger than 0.5 centimeter, the large microplastics, and then small microplastics. And I think that's going to be like the 1/10 of a centimeter size. And below that right now, we don't know that we'll be able to identify whether it's a plastic or a particle. So we're kind of in that 1/10 of a centimeter to a centimeter range. And that's where we're going to start out. And next time you hear from me, it might be totally different. So that's where we're starting from.
I asked the question because I hear in the press that there are nanoparticle sizes that,
Yes.
get incorporated into, flesh, into human and animal bodies. But I guess we're not outfitted to measure those.
No, and so that I'm realizing I might have actually just, when I shared my screen, did you see my Word document? Or was it? Okay, you might not have, but yeah, so the smallest one are those nano microplastics, and we just don't have the capacity to do that right now. And so we're thinking we're doing the presence absence and like the just about 1/10 of a centimeter to 0.5 centimeter. And we're looking at those right now. And depending on whether or not we see that, there are some labs. I know there's some in Connecticut, and the Ocean Conservancy worked with some folks near the Hudson River, who you can send samples, like once you find presence versus absence, you can then send the samples to them and they can do that, so that level of identification. And they can even tell you, like if there's a fiber, they're able to tell you, and of course, you pay an arm and a leg for this, but you tell them, they tell you there's this fiber, and they can tell you if it's like a hair or a piece of plastic. And if it's in hair, they can tell you if it's human hair or if it's hair from a dog or a beaver or a squirrel. They can tell you all that. And then for plastics, they can tell you what type of plastics and what the chemical breakdown of that plastics are. So in the future, open to thinking about that, but for right now, just working on the identification of presence absence in that size range.
Thank you.
Yeah, of course. You're pushing us to greater limits, which is good for us. We like to see it. I am gonna just toss my email, and because I think you've probably all been communicating with Aliki about logistics, which is great. But if you have more questions about the process or how we came up with it, or if you want to read any of the information or the articles that we've been working with, if you're just curious, I know some folks work better with all of the information, then feel free to reach out to me. I don't see any more questions. We're about 6 minutes out from the end of our time. So I guess if folks don't have any more questions, then we can wrap up and just know that you can expect some emails from Maliki about logistics and who's sampling what, and some information about how to get the supplies and the timing. And I will specifically look at the Haddam site and reach out to the volunteer selected for the Haddam site, and we can talk about that. And again, because we're only doing 13 sites and we're doing them twice, there's a lot more space. For the bacteria sampling, we're collecting, 70 to 100 samples a week. And so we can't be there for all of them. But if there are questions about site-specific questions or support needed, I know I and Aliki are available to help. It's a lot easier when there are 13 sites.
Gabriel, there's one more question. Oh, sorry.
I was just curious, are you funded for just 1 year, or is this going to be ongoing?
Well, I'm realizing that we're recorded. I want the Massachusetts Environmental Trust watches this. I want them to continue funding us if they look at our recording. But luckily, the initial lift really happened already. So a lot of the funding that we did, a lot of the funding that we used went into our time to develop the program. The meetings that we had went into buying the microscope, went into buying the filter funnels. And so we were able to purchase, like the microscope, that's more than a 1-year investment. And so we have a lot of the supplies to go through and do more samples this year. And all that to say, yes, we hope to continue this based on what we find. And I think that my hope, my pie in the sky dreams is that we continue to fund it to kind of narrow in even more and be able to do some of those questions, ask some of those questions that Keith had asked. Can we look at smaller particles? Can we identify where the plastics are coming from? Can we look at chemical makeup? Can we, there are different types of microscopes that use different types of polarizing light that can tell immediately if it's a plastic or a fiber. And so I'd like to keep investing in those technologies, but year 1 funded, year 2 enough supplies to do. And so it's just kind of looking into the future. Once we get this first pilot year done, where can we take it from there? And I think there's a lot of space to take it elsewhere. I could have just said yes or no, but that's my long-winded answer for that.
Thank you. That's very exciting to hear.
Yeah. Yeah, whether it's adding more sites, whether it's thinking about where are we sampling based on density, based on tributaries, based on wastewater treatment facilities. There's a lot of different ways that this can go. And so the initial funding supported these 9 sites and the purchase of our first round of equipment. So we could take it a lot of different directions.
Great. Thank you so much, Gabriel. And thank you everyone for participating. If there are any more questions, you have my contact information, and Gabriel just put her contact information in the chat. And you should expect to hear from me with the recording this afternoon and early next week regarding supplies delivery, blah, blah, blah. Great.
All right. Thank you so much. Have a good day, everybody.
Thank you, everyone.
Bye.
Bye.
Thank you.